Now, this is tutorial 4. In tutorial 4, we are going to look at turbulent flow rather than laminar flow. For this one, the first task that you have to do is to calculate the entry length for the pipe. You have again been given the pipe diameter, the pipe, but not the pipe length, and the fluid properties as well, the density and the and mu. So to calculate the entry length, you need to go to the end of the tutorial. So empirical results will give you that your entry length is equal, entry length over the diameter is equal to 4.4 times Reynolds number to the power 1/6. Using that, if you calculate for these values, you will get a result close to 2.04 meters. So for the length, you can use that, or you can use a slightly longer length, about 2.5 meters perhaps, to accommodate the full region. Then what you do here is you, in here, rather than doing a full cylindrical fluid element for the simulation, you get a quarter of a pipe. You simulate the quarter of a pipe. When you do this, you define two symmetry planes because you assume your x and y velocities to be symmetric or axisymmetric in this case. And all the changes will take place along the z-axis or the axial direction. So in the first part of the tutorial, you are taught how to create a cylinder again and split it so that you will get a quarter of the cylinder for your simulation. And then what you have to do is you have to go back to your tutorial 1 and 2, rather tutorial 1, to create a mesh. So once you have created the mesh, then what you do is you set up your problem again using ANSYS. One thing that I have to tell you before starting doing the ANSYS setup is that once you have created the geometry, the next thing that you have to do is to update your fluid. Update your ANSYS workbench. Go to ANSYS workbench, right click there, right click if you see something that is not a tick, and you right click that, and then it will update what is in there. So if you update it, if you don't update, you can't see all the meshes that have been created, etc. Okay. And then once you have created the geometry, then you go to meshing, you get the mesh, and once you have updated everything, you will see that your mesh is already been created. Then what you do is you set up the problem now for a turbulent case. Earlier you used a laminar case setup. Now you set this up for a turbulent case. Follow the steps here one by one to set up your problem. In here, especially, you can see that you have a viscous model. Earlier you had a viscous model. Your viscous model was laminar. Now you change your viscous model to K epsilon, or it's a turbulence model. Okay. And this is not the actual window you get. This is the initial window you get. You need to change your near wall turbulent, near wall treatment, etc. Once you have set up according to this tutorial here and given the boundary conditions, so then you can run the simulation again. So this follow step by step in this tutorial. You need to read very carefully, and then you when you have run the simulation, maybe you may be You might need to run 4,000 iterations to get a good result. And then your result is there. Then go back to your tutorial 3 again, where you were asked, where you were instructed how to do the plots. You follow tutorial 3 to do the plotting. Once you have done this, you have completed your tutorials fully. Now, these are brief instructions on how to do your tutorials. Now we will go back to your assignment. Now for the assignment, once you have done these 4 tutorials or the 2 fluid flow problems, what you have to do is to slightly change these dimensions and or the fluid properties to have a unique problem for yourself, and follow the steps that you followed in the tutorials again, and then you will have 2 solutions, rather 2 main solutions for your laminar problem and a turbulent problem. But in addition, you need to do a few measures. You need to change the measures and do a simulations, because you need to do a mesh study. And also you need to run this turbulent case with a few turbulence models, a couple of turbulence models at least. Then what you have to do is to plot your results. You can do a pressure plot, you can do a velocity plot, and you can do a vector plot. You use them for your report. I already gave you instructions on how to do the report. And once you have followed those instructions, you will be able to complete your assignment. And if you have any problems, I will be available in my office from Sunday onwards, and from Sunday afternoon onwards. Yeah, so you can come and see me. Or I gather that Dr. Musa has created a WhatsApp group, so I will join myself in there as well. And if you have problems, put in there. Okay, good luck with your assignment. I have given you an extension until next Thursday. If you have problems, just get in touch with me or maybe Dr. Musa as well. Thank you.